Today we're going to be talking about terminations. When installing branch circuits, one of the most important parts of that installation is making those terminations and making them properly. So today we're going to talk about a little bit of the history of terminations and some of the variety of different types of items that are available to make those terminations with. So let's get started. So terminations, wire connectors and push-in connectors. The importance of terminations cannot be overstated. The weakest link in a circuit is most likely the termination points. Unless some sort of physical damage has occurred, the conductors in a circuit are not typically where the problem starts. Loose connections, galvanic corrosion, and oxidation or improperly installed termination devices are often the catalyst for electrical hazards, damage, and fires. The story of wire nuts dates back to the early 20th century when electrical installations were becoming more prevalent. Prior to the invention of wire nuts, electricians relied on time-consuming and potentially hazardous techniques such as soldering, taping, or using twist-on connectors. And as you can see in this picture here, that is what is called knob and tube wiring. Those splices were basically just twisted together. Soldering by hand is a time-consuming and inexact science, and there are hazards associated with using molten metal and lead-based solder. Early in my career, I worked for a contractor that we actually soldered our joints in residential homes. The company owner advertised it as we make the best splices in town, and I'm sure he was right. Those splices were not coming apart, and they were definitely arduous to put together. But those splices did not have any connection problems. In order to reduce installation time and make it easier to fit connections into smaller spaces, the twist-on connector was born. The first iteration of wire nuts were simple, cone-shaped devices made of porcelain or ceramic. These early designs were manually twisted onto the stripped ends of wires to create a secure electrical connection. Although effective, they were limited in their capacity and had the potential for loosening over time. And I have used wire nuts like that before. I've taken some out of older homes, but I've also used wire nuts like that in, like I used to do a lot of service work in restaurants. And if you were changing out a rheostat on a stove or something like that, the splices made behind that termination panel there could not be made with a regular wire nut because that plastic wire nut would melt. You had to use porcelain wire nuts. In the mid-20th century, a significant breakthrough occurred with the introduction of plastic wire nuts. This marked a turning point in the history of wire nuts, as plastic materials offered numerous advantages over their ceramic predecessors. The twist-on connector was introduced in the United States around 1933 by electrical contractor William Marr. Wouldn't you like to be the guy who invented wire nuts? This connection method, also known as wire nut connectors, was the norm until recently when companies introduced more reliable connection methods, such as lever or push-in connectors. Now, this is a great point for me to stop and say, I know there's lots of people out there that don't think too much of those push-in connectors, or the brand name typically used is Wagos, although Ideal and many others make them. But this presentation is not to tell you, hey, Wagos are bad and wire nuts good. This is really just presenting all the information. Just wanted to clarify. Plastic wire nuts provided improved insulation, better resistance to heat and moisture, and greater compatibility with a variety of wire sizes. Additionally, plastic wire nuts were easier to handle and install, speeding up electrical connections and reducing installation time. Over the years, wire nut manufacturers have continually improved the design and functionality of these connectors, and the development of innovative features has enhanced their performance and made them even more reliable and convenient for electricians. One notable advancement is the incorporation of internal spring mechanisms within wire nuts. These springs apply continuous pressure on the wires, ensuring a secure and long-lasting connection even in challenging environments. Moreover, the introduction of color-coded wire nuts has simplified identification, enabling electricians to quickly select the appropriate connector for specific wire combinations. Today, wire nuts are manufactured using high-quality flame retardant materials that comply with industry standards and electrical codes. These standards ensure the safety and reliability of electrical connections in various applications. And while I've got this picture up, check out that drill bit, as one might call it, there at the bottom. Those typically come in you get a bag of wire nuts, you might have one of those in it. I think that they can work if you're careful with them, although I typically recommend when I'm teaching apprentices not to use them, because I think you can certainly make a mess of a group of wires if you're using an impact drill or something like that with that sort of a bit. So can be hazardous. Leading manufacturers produce wire nuts that can accommodate a wide range of wire sizes and types, including solid, stranded, and combinations of copper and aluminum conductors. Additionally, modern wire nuts incorporate features such as gel-filled capsules for moisture resistance and increased durability in outdoor or damp environments. The history of wire nuts reflects the ongoing evolution and innovation in the electrical industry. From humble beginnings as ceramic connectors to the modern plastic counterparts with advanced features, wire nuts have transformed the way electrical connections are made. These small but crucial devices provide electricians with a safe, efficient, and reliable method for joining wires. As technology continues to advance, we can expect further enhancements in wire nut design, materials, and functionality. The history of wire nuts serves as a testament to the importance of continuous improvement in electrical connectors, ensuring the safety and efficiency of our modern electrical systems. And as you can see in the picture in the background there's lots and lots of different types. And what I have here is I've basically taken the Ideal brand and went through and pulled out what a handful of their foundational types of wire nuts that they have on the market, just as an example. So first of all, there is the American Classic since 1928. This American Classic is the original connector that started it all. The wire nut wire connector has 5 color-coded models that cover a full range of applications from 22 to 6 AWG. I have to be honest and say I've never been a fan of these wire nuts. Here's a little bit larger version of it. And you can see at the bottom of the page here, there's the chart that tells you how many wires you can actually put in a wire nut. And all wire nuts come with that information. I'm not sure how many people are actually reading them. I think some people use the gauge of if the wire nut is red and there are white stress marks in the plastic on the outside of it, perhaps I put too many wires in it. Now, here's the Classic that I have used since I started in the trade, and that's 40 years. The high leverage wing. Basically, I would take a pair of strippers and put it on each side of those wings and then twist the wires together. We'll talk about wire twisting here in a bit, but twist the wires together using the wings on the wire nut. And of course, there's the yellow version of this also. Varying amount of wires you can get inside of these wire nuts. And then this came out, I want to say it came out somewhere in the 1990s. The twister wire connectors, comfortable swept wing. This wire nut was the Una wire nut, where I believe it was supposed to serve where people were using the yellow wire nuts and the reds. You could use this, and this really kind of covers it all, I believe. Not a bad wire nut. And then this, which looks like the Iron Man wire nut. And from what I understand, these are great wire nuts, but they are expensive. But it's kind of got the little skirt at the bottom of it, which when making splices, and as I'm teaching students to make splices, one of the biggest problems I have is they make the splice or get the wire nut on, and they either don't twist it on enough or they've stripped out too much wire, and there's bare conductor hanging outside of the wire nut. And this is the B twist, which I believe they're calling this, if you look at the bottom of this page, the Buchanan, which that actually was a brand that I had started with in the 1980s when I started in the trade. Now, the weatherproof above grade, underground, below grade wire connectors. These wire nuts are designed to be installed in wet locations, underground, which is a great idea. I've certainly, and lots of electricians have had this happen. You install splices inside of a box that's outdoors. Well, maybe you got a good seal on it, but you could still have condensation inside of that box. I've opened up the weatherproof bell box before and looked inside of it, and there's literally water standing inside of it, and it's live. So yikes. These wire nuts are designed to withstand the elements. Below grade, ground use, underground wire connectors are designed to secure and protect connections in a wide variety of below-grade wet location and direct barrel applications, including quasite boxes. Quick and easy installation saves time and energy, eliminating the need for heat shrink, resin packs, and multi-step corrosion kits. Yeah, that's pretty wild that you can actually use that below grade. Okay, now this is the Twister ALCU, so you know that means it's rated for aluminum and copper wire connectors. The only twist-on connector for aluminum to copper connections, so says Ideal. The specially formulated antioxidant compound prevents oxidation on aluminum conductors for improved conductivity and cooler connections. It is UL listed and CSA certified for aluminum to copper connections. Well, here's a picture of one that, something didn't go right here. I have taken many of these out of homes where they look just like that. Looks like somebody took a blowtorch to it. They are still UL rated. You can still buy them at the local supply houses. I do not recommend the use of these. What these are for is if you have, let's say, I'm going to use a residence as an example. You have an existing home that was wired probably in the 1960s and has aluminum branch circuit, old technology aluminum wiring in it. That is not going to be 8800 series aluminum. Those splices have been known to have problems because of galvanic corrosion and oxidation. You see, the difference between copper and aluminum is this. Copper, when it is exposed to air, there is a film that's created over the top of it, which is actually, that film is a good conductor of electricity. The same thing occurs with aluminum. However, the film that's created over the top of aluminum is not a good conductor of electricity, and thus, as a result, will create resistance in between those conductors being joined together. This was a big problem in the 1960s. The aluminum wiring industry got involved in when there was a shortage of copper and wanted to get into the branch circuit game, and it didn't turn out too well for them, and there has been fires and things like that, and they have since stopped making this type of conductor, and there's been an advancement in aluminum wiring manufacturing, which I believe really happened in the 70s, and that's where you get that new 8800 series aluminum wiring, as is mentioned in our National Electrical Code. Now, if you are doing a home and you are resplicing everything in the home because it has branch circuit old technology aluminum wiring in it, one of the best products I've seen out on the market is this, the Alumicon, which is basically what I call a pedestal bar, a miniature pedestal bar. And you can see from the picture here, you can install your conductors. If you were making a splice like in the box there, install the two aluminum conductors and then maybe a ground pigtail, put that all together, close the lid, and now you have conductors that are joined together appropriately, and you're not mixing alloys. I'd say this is a highly effective way to do it. The downside is those bad boys are going to take up some room inside of that box. And oftentimes the boxes in the homes that would be of this age are probably not the appropriate cubic inch space to accommodate that. So that's going to be your problem. The problem is not necessarily with the aluminum wiring itself. Aluminum is a good conductor of electricity. Obviously, it's used quite often from the larger conductors, multi-stranded conductors, and the utility companies, that's predominantly what they're going to use. But in this level here at the branch circuits, that is where the problem lies. Now, there has been a push forward in what is called copper-clad aluminum in the last two code cycles, the 2020, 23, and now the 26. It seems like the industry is trying to push copper-clad back into the market. The aluminum wiring problem that lasted from the 1960s into the 1970s occurred in the US and Canada. Aluminum wiring was a cost cutting measure. However, adequate engineering had not been done on connections, branch circuits, as these connections were not capable of coping with thermal cycling. The problem was the wire used had too high a yield strength and too poor a creep behavior. And by the term creep, they mean, for instance, when you think about when you put a curl around a screw on a receptacle, if that was aluminum, over time it would creep out from underneath it due to expansion and contraction due to heating and cooling down. Note this was a problem with only number 12 AWG and number 10 AWG branch circuit connections. If in the 1960s, if you were running a 20 amp circuit, you'd be using number 10 because you typically go up a size because it's aluminum versus copper. Aluminum feeders, service entrance cables, and other high ampacity circuits can safely be installed using aluminum because the connections there are not subject to the same problems. And those are multi-stranded conductors also, rather than just a single conductor. All right, push-in connectors. Now, before I get into this, I just want to say this is presenting information. We are not advocating for anyone to use these or not use these or either way. We're really just trying to put some information out there. I know there's lots and lots of different pieces of equipment out there to use, so just trying to give you a fair view of all of it. So these connectors saved installation time and required less operation and reduced cost. However, the advantages came with disadvantages. Most twist-on wire connections are largely dependent upon installer skill and as such remain inconsistently reliable. The color coding of the caps, the number needed, and the wire gauge that should be used with each can be confusing and potentially hazardous as well. Like older connections, you must mate the correct wires together with the appropriately sized cap in order to form a proper connection. Terminal blocks were later developed to provide installers with modular, insulated blocks to secure multiple wires together. Terminal blocks secure wires within individual terminals, often arranged in a grouping, and connect to a ground or switches and outlets. Terminal blocks are becoming more common in residential wiring, but have been the norm in the industrial sector for quite some time. Today, this technology has expanded to include push-in and lever-actuated connectors that completely eliminate the need for installation tools and automatically ensure strong electrical connections. Or at least that's what they say. Here is the Wago's cage clamp. And obviously, by the date, it's been around a long time. While many residential installers still use twist-on wire caps for electrical connections, the industrial world has taken the next step. Zero Zone, a company that makes coolers, freezers, and refrigeration systems for commercial retailers, transitioned from twist-on wire caps and screw-top terminal blocks to Wago's 222 series push-in cage clamp connectors. And here you can see this is kind of interesting, where it basically is on has a platform mounting, and then it also is mounted on DIN rail. What will you use? There is no telling what type of innovations the future holds for wire connectivity. Connector designers continue to make connections faster, stronger, more durable, and ruggedized against harsh elements. The old methods of splicing may never entirely go away, but connector manufacturers will continue to evolve and come up with new and exciting products. Fires caused by poor connections. Per a November 2021 article in EC&M magazine, poor connections are the #1 cause of electrical fires in the United States. This is consistent with statistics from Ontario, Canada also. And these terminals you're seeing here, those are actually terminals. It's a test, but it's a terminal off of a receptacle. You can see all the way to the right, it looks like it's literally welded. The common connection types today are twist-on connectors, screw connectors, spade or D-lug connectors. While soldering or welding connections exist in some applications, most connection types depend on mechanical force for their integrity. This in turn requires sufficient force and good surface conditions at the interface. All metals exposed to air oxidize, but excessive oxidation can result in failure, as can dirt or other foreign substances. As I was saying with copper, there is a film that's created on copper as soon as it's exposed to air. That is actually a good conductor of electricity. If you ever seen the Statue of Liberty, it's all green. That's galvanic corrosion. or maybe a roof that has some copper on it, then that's galvanic corrosion. Today, the bulk of fires due to poor connections involve copper or brass as the main metals, with smaller amounts of plated steel also being encountered. Thus, most commonly, we are not dealing with poor design engineering, but with poor workmanship when failures occur. And if you look at this picture, you can see, well, there's a few different violations here. Insulation, broken insulation outside of the box, but they've used the big blue, what I call the dreaded big blue wire nut to join what looks like, I don't know, a couple of number twos or number sixes. I don't care if that wire nut's rated for that or not. That is not a good splicing method with a conductor of that size. You should be using a pedestal bar or some type of device of that nature. The most common type of poor workmanship is inadequate tightening. In a small fraction of the fires, environmental contamination can also be a factor. Salt water or salty air contamination. Some of you have probably seen videos out there that show people using these drills and things like that. That may make you faster, more efficient. I have concerns that those are potentially not good connections. I'm not saying that they're not. They very well could be if used properly, but I think things could get sloppy. I was told the sign of a good electrician is how good a splices that he makes. I was told that as an apprentice many years ago. Most poor connections are due to sloppy workmanship. This photo on the right shows an example where bad design, not bad workmanship, led to overheating of some lamp connectors. The load of 12.5 amps was substantial, yet the design required the electrician to use a miniature screwdriver, which could not supply adequate torque. More common are failures of screw connections at duplex receptacles. The photo above shows a lab experiment depicting a progressive failure at such a connection. Poor connections can appear glowing and reach temperatures in excess of 2,000 degrees. Yikes. It is important to appreciate that glowing may not be steady, but rather have an intermittent character. Not all glowing connections lead to a fire. Instead, a significant fraction will simply open up and no longer function. This is why finding dead outlets in a building should be a major concern. The likely reason for a dead outlet could be a bad connection that after a certain amount of time opened up. And I've gotten that call where a person called and said, the receptacles in the back room stopped working, but then after a while they came back on. From that expansion and contraction of splices, it heats up, and then cools back down, and maybe it comes back together and makes the connection back. Now, to twist or not to twist. And I believe that's a debate out there today. And I'll say in advance that, I, as a 40-year master, I have always twisted splices together. That's the way I was taught. I believe that twisting the splices together will ensure that that splice stays together, even if, let's say, the spring inside of that wire nut failed. It's very unlikely, but nevertheless, even if it failed, if you twisted your wires together appropriately and tightly, I believe that splice could still stay together. So what I've created here is just a handful of directions or installation instructions that came with some wire nut manufacturers. So this one, of course, is ideal. And there says, where it's underlined, pre-twisting acceptable, but not required. Okay? Gardner Bender, pre-twisting is unnecessary. And this is one I just found on Amazon. Never heard of these guys, but pre-twisting, unnecessary. And another Amazon brand, pre-twisting, unnecessary. I did not find any that said that if you twisted your wires together, that you were damaging the conductors, although I had someone tell me that. And so twisting together, I believe, is best case scenario. Many of the directions under say that it's not required. Again, as we just heard, poor connections could be not because of the engineering or the manufacturer of the splicing device, but the worker who is installing the splice. So no instructions found indicating not to twist conductors together, only that it was not necessary. So, if I'm going to make a splice, first of all, I'm going to strip out probably about 1 inch of wire, typically, if I'm just joining two conductors together. And I'm going to trim some of that off once I've made my splice. I always take them, fold them together, cross them like this. Watching the camera here, make sure I'm showing what I want to show. Get that first twist. And I'll take my alignments and twist. And as I'm twisting, I'm pulling down to create that nice braid. And I'll also twist to where it has a few twists on up onto the wire. Then I'll trim it down to where it's about 1/2 to 5/8 of an inch. Put my wire nut on it, twist it until I get twist up on the wire like that, 2 or 3 twists. And that is a splice that'll be good forever. Now, when you are making connections to a, let's say, I've got green wire, but let's say we'll make a connection to a ground screw. When you're making that connection, you want to make sure that that is in the direction of counterclockwise, or excuse me, clockwise. You want to tighten the screw to where it's pulling the wire up onto it, not pushing it off of it. So I always hold them like this. That way I'm holding the wire with my 2 fingers and then tightening it with a screwdriver. And notice the insulation stops right before it gets up underneath the screw. Now, you have some of these devices like a 4-way switch like this. They are not designed to have a curl for a connection point. Basically, what you're going to do is strip out about, 1/4 inch to 3/8 of an inch. And that plate inside of there, you want to make sure the plate's falling down inside of it. Place your wire underneath it. Again, I'm holding it together with my 2 fingers to kind of hold the wire in place. Then tighten it. I know it's green wire, but it'll work for this. And then that gives me a good connection. You know, the big question is when you're making terminations like this, should we be using cordless drills? Well, I can tell you this. When you're making splices like this to a device with a cordless drill, I think it's questionable whether or not you're actually getting the appropriate torque. So you must consider that. These are the termination points where they can cause overheating if they're not appropriately tightened, and that sort of thing. TFCI devices oftentimes come with a similar termination point. It's basically a plate down inside of there that you have to make sure that it's open and you're getting your conductor in between those plates, placing it down inside of it like that. Tighten her up. Make sure it's good and tight. And there you go. This actually has 2 holes on it, so you can actually go on either side of it and make an appropriate connection. It is rated for that. So, these little gems, these things, you know, they're out there. A lot of people using them. You know, it's really up to the installer. You know, make sure that they are rated for what you're using them for. The old steady, you know, these, not these. I know everybody's wondering, is there a spring inside of it? No, there's no spring inside of it. Those are just for fun. I'd hate to see the wires you'd have to put inside of that. These, I've seen too many of these melted, literally melted down. Can't say that I'm a recommender of using the big blue wire nuts. Also, if you're making a splice like in a multi-gang box, and let's say you have you know, a bunch of hot wires that are coming together, and then you've got to make several pigtails off of a 4-gang box, we'll say. When you put all of those in there, and then you have all of those wires going out for the pigtails, and you use one of these big blue wire nuts, I think it's possible that you could have all those wires together in there like that, and then you may have a few in the middle that might not be making a good connection. Therefore, the option that I give and I teach is that if you were making a box like that, rather than make one great big joint, make two smaller ones and make a jumper in between. It's code legal, there's nothing wrong with that. And make appropriate size joints, not ones where it's just like this great big wad. I think that's potential to have, again, overheating and problems. So, okay. Well, I hope this has been informational and learning experience for you. And be sure and visit our website, like and subscribe our channel here. And my name is Mike Barley. I'm with Electric Lab, and thanks for watching.